Hello everyone and welcome to this video. So today we're gonna cover the operation management and also the crossover chart. And so basically we covered the process strategies in our previous video. We covered some of these strategies and one of the main strategies in the operation management, and we said that the most used strategies were the process focus, the repetitive strategy, product focus, and mass customization. These were the major strategies used for our operations, and so we covered also the differences, and now we are gonna cover what we call the crossover chart example. And so basically, it, the crossover chart example evaluates different softwares, okay, and different methods of producing a specific service or product. And so it calculates based on the fixed costs and also based on the dollars required per, let's say, product or per unit. So it's based on the fixed costs and also on the variable costs. And so some algorithms or some softwares will have lower fixed costs, but also will have a bit higher rates per unit or more variable costs. Some others will have something in between. And so here in our example, we see that software A has about $200,000 in fixed costs and but has $60 per unit in variable costs. And so if you see software B is different than software A in which that it has a higher fixed cost but a lower variable cost. And so software C now has even higher fixed costs and very low variable costs. And now this will help us in order to identify the most suitable software for our different process strategies. So we do have different process strategies, and each strategy will need different variable and fixed costs based on that strategy. Because, for instance, in the product process strategy, so if we notice, for example, the process strategy has very low volume and has high variety, and so it has it needs more variable costs. It has lower fixed costs. And so if we go also in the comparison part, you're gonna see that the process focus in terms of costs have low fixed costs and more variable costs. So these variable costs are very high. And so for that, we're gonna need a strategy for if we're gonna choose to produce our product using the process focus, then we're gonna need a strategy or a software, like for example software A has a very low a relatively low fixed cost and then has a relatively high variable cost. That's basically the strategy that we will need for this one. Now there are different strategies. For example, the mass customization, it's a bit different. It's gonna have high fixed costs and lower variable costs. So because we are producing basically for the masses and we want to produce and sell immediately, and so the fixed costs are gonna be higher, and the variable costs are typically gonna be lower. Based maybe these could be based on demand. And so now also there is a way to calculate this and to numerically try to predict this number. And so here we have our crossover chart example. Okay. So we can start here. For example, this is software A. Now software A has a fixed cost of $200,000. You add to it 60, which is the variable cost for software A, and then you want to find. So basically, what are we trying to find here? We are equating the total cost for. So we are equating the total costs for basically software A, and we are assuming the volume is V1. So we don't know the volume. We want to have any volume, use any volume. So we choose a volume which is V1. And then when we assume that volume, we multiply it by the cost per unit to give us the total cost. And so we did the same also for software B, which is 300,000 plus 25 times V1. Now this, when we try to solve for V1, we're gonna get basically 35 V1 equal 100,000. Now V1 is gonna equal some value, and that's basically the value that we get is the number of units at which software A and software B are of the same profitability. And so if the number of units that we are producing crosses this number, then we're gonna use the software that has the better profit for us, which is the software that is, say, software B, since we have more variable costs and less variable costs and more fixed costs. So then, and high volume. So software B is gonna be better for us. And we can do the same when we compare, for example, software B with software C to find the breaking point from which we can choose or decide that we're gonna use a specific software. So let's say, for example, here software A. Say software A is most economical from 0 to 2,857 reports. So reports is basically units, or yeah. And then here we're gonna basically do the same. So the total number of units 300,000. We're gonna add to it 25, which is the variable cost, and multiplied by V2. This is now the number of units that can be produced in order to equate the profit. We're gonna equate it to 400,000, and we're gonna add 10 times V2. And so V2 is gonna equal this number. And now software B is most economical from the range. Okay, so first this range, this value, 2,857, which is V1, to 6,666, which is V2. So software B is most economical from in this range. So if you have a range that, and we forecast that, for example, we need to produce an software A is gonna be more. We're gonna more than 6,000. We're gonna use software C, and that's basically a range. So there is a range, and here we can see it in our. And so we can see it in this graph. Okay, so we can see we have the fixed cost. Okay, and we have the variable cost, and then we have also here for process B have a fixed cost and a variable cost, and we have process C fixed cost and variable cost. And if you can notice, as the fixed costs increase, the slope or the change in the variable costs decrease. And so as you can see here, when we have a smaller fixed cost, we have a higher slope, which means a higher change, a higher price per unit. Now, if we have a higher fixed cost, we will have a less steep slope. Now, as you can see here, So, and this is basically the cross line here, if you can see it, is basically the line where two softwares have the same profitability. And so it's the most profitable software is gonna be the one which resides the furthest down. So if we are going to produce from 0 to 2,857 units, the most profitable process is gonna be process A, which is this in the dark gray color. This is gonna be the most profitable one. We're gonna produce from 0 to V1. And if we want to produce a number of units now from V1 to V2, then the most profitable process is gonna be process B. And if you want to produce more units, more than 6,666, then our most profitable process is gonna be process C. As you can see, focused processes. Now, focus brings efficiency. Focus on depth of product line rather than breadth. So when we focus our products, when we focus our work in, let's say, a facility, it it gives us more efficiency. Okay, so for instance, and mass customization is an example of this. So for instance, companies like Lee's have focus. They are focused on producing data chips. This tends to be efficient. This process tends to be efficient for Lee's, and they focus on depth of the product rather than breadth. And they are focused, so they are focused products processes, but they are also more broad processes, and each of them has uses and they have their customer demand. And so the focus can be basically on customers in marketing in general, in our strategies and producing products. It could be in products, it could be on services, technology, for example, finance services, providing um, providing specific devices, let's say, producing specific device for specific niche like Apple, you know, mm, let's say clothing. So clothing also they are focused on sometimes in their products they are focusing clothing, and sometimes focus on customers. So some product brandings they're focused on high customers who are willing to pay. Okay, and so yes, the different types and the different focuses that can be really done. And so there's a selection of equipment, okay, and decisions can be complex as alternate methods can be available, okay, and that's important in selecting equipment since there are many complex and different methods in which we can, you know, we can do things, can produce things, and that's why selection of equipment is very important. And this is basically done by the procurement team. Okay, so the selection of equipment and buying of equipment is done by the procurement team, and many factors influence this selection process, and these include cost. So cost gonna affect the selection of equipment, cash flow, the amount of cash the company, the business is generating, and also market stability, quality, capacity, flexibility. All of these are factors that may influence the equipment that we select. Also, we have flexibility, and flexibility is the ability to respond with little penalty in time, cost, or customer value. And being flexible is important, especially in our today market. We need to respond to our customers fast in different ways and different methods with minimal costs and provide maximum customer value. And that's basically what many companies try to do now, is to be very flexible in their products. And so this, for example, say we have a company, let's take Apple. Is Apple flexible? Well, I'll say yeah, relatively. So they produce kind of different products. They produce different smartwatches, different iPads, laptops, different stuff. And they try to appeal to a whole broad range of people from by providing different different specifications with different costs and also different segments. Yes, maybe Apple is more of a brand and not focused on the masses. Actually, it's focused on the masses, but it's not like it's more of targeting more middle class people, I'll say, but they have flexibility. So it could be also a competitive advantage, and we know that our three main competitive advantages are differentiation, is doing something different, and or doing it better, and also we have responsiveness, is being responsive, responding faster than competitors, and this is notable in applications like groceries deliveries. So, for example, in the UAE, we have Carrefour. Carrefour is a groceries app that's been providing services now for more than a year, in which they deliver groceries in less than 1 hour, which was something not possible 2 years before, 3 years before. That's something that started to emerge, which has a high market actually. It's a very broad market. So it has a big market and no one was covering it. So Carrefour started doing that, and now they are like, I see them everywhere with their application. And so this is the responsible part, okay. And also Carrefour are have uh, have have less costs, so they also compete on cost. Okay, so Carrefour compete on cost. They have the cheapest cost and the lower cost in the market in general. And but how? Yeah. So back to flexibility. Flexibility can be added to our three main differentiation or competitive advantages. We said differentiation, cost, and responsiveness, and we can add to that flexibility. But the problems with the flexibility is that it could be difficult and expensive. Okay, but there is a market for that, and so without it, change may mean starting over. So you are not flexible. If you want to change, you're gonna change, start from the beginning, and that's really not something very, let's say, efficient. If you're gonna need to change every time and start over, then what is what is your company? You need to be able to adapt without starting over, uh, except if you really need to. And so we do have now process analysis and design. So when analyzing and designing any process, okay, we need to ask a couple of questions. So first, our first question we can ask is that, is a process designed to achieve a competitive advantage? So is our process designed to achieve that? Does the process eliminate steps that do not add value? And does the process maximize customer value? Will the process win orders? So these are all questions we can ask. So as you said, is the process gonna maximize also profits? Is it gonna maximize profits for our product or service or technology or whatever that we are selling? So these are a couple of questions that we can ask. So for example, if you choose a process, let's say the repetitive process strategy. So we're gonna ask, does it achieve a competitive advantage? So for example, a motorcycle company. Now they have, let's say, customization. The motorcycles, not a lot of customization, but a degree of customization in there. in their motorcycles. Now, does this provide a competitive advantage? Well, maybe depending on the market, depending on the need of the customers, the wants. Now, this could be a competitive advantage if something nobody's doing and something that people want. If something that nobody is doing because people do not want it, then doing it is not gonna be a competitive advantage. So you're gonna make sure it's really adding a competitive advantage to you. And you're gonna think also, does the process eliminate steps, okay, that we do not need? So that's important to maximize efficiency and output. So some steps maybe can be eliminated. We can try to work on them and think of ways to eliminate them or make them more efficient. And also we want to maximize customer value. So does a process maximize the value for the customer? Well, maybe we need to try to do that by maybe adding steps that add value, or maybe eliminating steps that do not add value in order to cut costs and benefit the customer and maybe competing in cost. And also with the process win orders, that's important. If no one is buying it, then why are we doing it? We need to make sure people are willing to buy. And so we do have some tools for process analysis and design. These include flow charts, which show movement of people or material, time function mapping, which adds time on the horizontal axis to a flow chart. Then we have process charts, which use symbols to analyze movement of people or material. Then value stream mapping, which expands time function mapping to see where value is added to the entire supply chain. Service blueprinting, which focuses on the customer and the provider's interaction with the customer and to identify potential failure points. So these are some tools for process analysis and design: flowchart, time function mapping, process charts, value stream mapping, service blueprinting. Now let's look at baseline time function map. Now, basically, if you zoom in, so the customer, let's see, let's check this. Okay, the customer orders a product. The salespeople process the product. Our sales uh, force, they process the product, and then the order is placed and it's taken to the production control. And there's gonna be some wait time in order to produce this product, and then it's gonna go to plant A. Okay, it's gonna also initiate the order, the warehouse, WIP. Okay, and WIP basically stands for, try to open my notes. So this is WIP is inspection, the inspection of the product or the order. So it goes also to the warehouse, and then it goes to plant B, house. Okay, and also it goes now, after it goes into plant A, plant B, it goes over the production process, then it goes to transportation. So it gets moved to another warehouse and wait, and then just you know extrude the product and the weight and the product, and also it goes to transport. So it goes back maybe to plant B. Okay, and then basically the product goes back to the customer, so he receives the product. So let's say this is an order of a Tesla car. So it's basically they take this long usually, maybe they take longer. So let's say this around 10, 20, like a month and a half, something like this. So I think it takes longer, but let's say it's a month and a half. Okay, so 52 days. Okay, so you have 52 days. So what products take 52 days to get delivered? So I think cars is the most suitable example here. And so we have our target time function map. This is now something different. Okay, so it looks like, so this is the baseline and then there is the target. Okay, so it looks like a more of, huh, yes, so this is the, yeah, so basically these are different time functions. So this takes 52 days, but this function takes 6 days. And so first the customer places the order, then salespeople or Salesforce process the order, and then goes to the production control. They take the order, you wait, and then the plant you print, WIB extrude, okay, and then you wait again in the warehouse and comes back to the customer. So it takes 6 days. So what the products take 6 days to get to the customer, maybe and 6 days to produce. Maybe we have it already produced. So maybe you order from Amazon. This is a process for ordering in Amazon. Maybe. So yeah. So no. So basically, this is like 6 days. The target time function is 6 days, around 6 days. The baseline time function is around 52 days. So these are different time function maps. So they are called maps. Both of these, they are both maps. Okay, and then we have also a different tool. These are the tools for process analysis we said. Okay, and the first ones are just the maps, time function mapping. Now we cover this. So we go to process charts. Now, as you can see, this is a chart, an interesting chart. Okay, so meat, patty, and storage. Whoa, that's a messy chart. It's an interesting one. So we have the date here, we have the sheet number, we have the chart by, and then the subject charted hamburger assembly process. Okay, okay. So this is for making hamburger. Okay, so so now meat, patty, and storage. It moves chart symbol. Okay, so okay, and we have here symbols, as you can see. So each shape represents a symbol operation, a circle represents operation, an arrow represents transport, a box or square represents inspect, and this shape represents delay, and a rectangle represents storage, and so. And so first, the meat patty is taken from the storage and taken up to transportation, okay, which takes 0.05 seconds. So you're just basically taking the meat patty in storage and taking it and then you know trying frying it, okay, to getting it to the boiler. And so and it's very interesting that these things are being documented. So why would you document that you're taking a meat patty from a storage? It's like nothing, 0.05 seconds. Well, actually, when we do optimization process and try to optimize the whole process of making a patty and delivering food, delivering hamburger to customers, these like fractions do matter, and it's very important to keep track of them. And when we optimize, they really add up. So if you neglect 0.05, 0.05, 0.05, all of these, then they add up to a great amount, which reduces our optimization if we are not taking them into account. Of course, there's going to be some variability, and we're going to take this into consideration, but we need to make sure that we try to take into account everything and not everything out now. So now we transfer this patty to the boiler, okay, and took us 2.5 seconds. We measure this. Now we do this once, not every time, of course, but we try to approximate and then try to optimize and use algorithms and data or optimization in order to make this optimized, okay, and then we use it forever. So we don't do this every time, of course. And then so yeah, so 0.250 seconds in the boiler, then it goes to visual inspection, 0.05 seconds, and then to transfer to the rack, 0.05, and then to temporary storage. Now this is to storage again, 0.15, and then transport, and then it goes to the operation assembly order, and then transport again and place and finish rack. So the whole process takes 3.15 minutes to make the hamburger. Okay, and also the distance is measured, the distance taken. So it's interesting, 3.5 feet. Interesting. And then we do have, yeah, and this is the number of times we had operation, transport, inspection, delay. We hope we don't have delay, and then storage. So this is the process charge, which is very interesting. Now there are some special considerations for service process strategies. So some interaction with customer is necessary, but this often affects performance adversely. So the better the interactions are accommodated in the process design, the more efficient and effective the process. So you need to find the right combination of cost and customer interaction. Now we do have the service process matrix. Now this is another tool. There are basically a lot of tools here. We're gonna go through. Now this is our last tool. Let's go through it. Service process matrix. So the service process matrix is just basically, so we have we have on the x-axis the degree of customization of a specific product or specific, specific product or process, let's say, degree of customization. And on the y-axis we have the degree of labor. Now the degree of labor is going to be low, the degree of customization is going to be low. We're going to have surface factory, which is airlines fall under this, which they have low degree of labor and low degree of customization. Okay, so they are not really customized and they don't need a lot of labor, just the pilots, the people who take care of the passports, you know, not a lot of labor compared to the people who are using these facilities. And so now as for the high degree of labor and low degree of customization, so retailing is an example. So warehouse and catalog stores, these are all examples of retailing, and they require a bit of labor. People who market these, catalogs and warehouses. Okay, people who work there, and basically they have very low customization. Also, commercial banking, they have a lot of labor but very low customization, so you can do very little things. Okay, some major things like opening an account, having a card, debit card, and all of typical banking things. But they have a lot of labor who are working in the front line and also in the back line, such as investors and stuff like that. So it has a lot of people. And for full service stock brokers, these are like fall in between degree of customization and they are high in degree of labor. So yeah, and there is also some limited service stock brokers. So they are, let's say, specialized, and they have some less degree of labor and also low degree of customization. Now, for professional services, which has a high degree of customization, these include general purpose law firms. So law firms have a high degree of customization, also high degree of labor, and they tend to be most expensive, of course, lawyers. and then and then we have law clients, which have a low degree of labor and typically, a medium degree of customization. Now we have the fine dining restaurants, as fine dining restaurants basically have low degree of labor and very high degree of customization. You have all sorts of dining and food options. And basically, we're gonna stop here. Thank you for watching. We covered the different tools for process analysis, and we're gonna cover the rest in a different video or in an upcoming video. Well, thank you for watching.